Chapter 3, Designing Functions. This chapter covers functions in Python and their role in designing software, the standard workflow when interacting with Copilot, examples of writing good functions using Copilot, reasonable tasks for Copilot to solve. One of the hardest challenges for programming novices is to know what a reasonable task is to give to Copilot so that it finds a good solution. If you give Copilot too big of a task, it will often fail in spectacular ways that can be extremely difficult to fix. What, then, is a reasonable task? This question is important for our use of Copilot but goes far beyond it. Human programmers struggle with complexity too. If experienced software engineers try to write code to solve a problem that's too complex without breaking it down into smaller, more solvable subparts, they often have trouble as well. The solution for humans has been to use something called a function, whose job is to perform one task. Functions help us organize our code and make it easier to think about and fix any bugs. There are various rules of thumb for how to write a reasonable function in terms of number of lines of code, but fundamentally, these rules try to capture writing something that 1. Performs a single task, and 2. Isn't so complex that it's hard to get right. For people who learn to program the old-fashioned way without Copilot, they may have struggled with syntax in code that's 5 to 10 lines long before being introduced to functions. At that point, it's natural for them to understand through experience that they shouldn't write more code in a single function than they can handle testing and debugging. Because you're learning to work with Copilot rather than syntax directly, our job in this chapter is to teach you about functions and what are considered reasonable and unreasonable tasks to ask Copilot to solve in a single function. To help you gain perspective on functions, we'll provide you with a number of examples in this chapter. Those examples employ the central workflow of interacting with Copilot, specifically the cycle of writing prompts, receiving code from Copilot, and testing to see whether that code is correct. In the functions produced by Copilot, you'll begin to see the core programming tools, such as loops, conditionals, and lists, which we'll expand on in the next 2 chapters. Section 3.1, Functions. Before we can learn about the details of writing a function, we need some insight into their purpose in software. Functions are small tasks that help accomplish larger tasks, which, in turn, help solve larger tasks, and so forth. You probably already have a lot of intuition about breaking apart large tasks into smaller tasks. Let's make that intuition concrete with an example. Suppose you found a word search puzzle in the newspaper that you'd like to solve. See Figure 3.1 for an example puzzle. In these kinds of puzzles, you're looking for each word in the word list. The words can be found going from left to right to left, top to bottom, or bottom to top.
Figure 3.1. Example word search puzzle.
At a high level, your task is find all the words in the word search. Unfortunately, that description of the task isn't helpful on its own. It doesn't tell us what steps we need to take to solve the problem. Try working on the problem right now for a couple minutes. How did you start? How did you break down the overall task to make it more achievable? One thing you might do is say, okay, finding every word is a big task, but a smaller task is just finding the first word, cat. Let me work on that first. This is an example of taking a large task and breaking it into smaller tasks. To solve the entire puzzle, then, you could repeat that smaller task for each word that you need to find. Now, how would we find an individual word, such as cat? Even this task can be broken down further to make it easier to accomplish. For example, we could break it into 4 tasks. Search for cat from left to right, search for cat from right to left, search for cat from top to bottom, and search for cat from bottom to top. Not only are we making simpler and simpler tasks, but we're also organizing our work into logical pieces. Most importantly, as we'll see throughout the chapter, it's these simpler tasks whose code we're going to ask Copilot to write and ultimately assemble into our complete programs. Taking a large problem and dividing it into smaller tasks is called problem decomposition, which is such an important skill in software design that we've dedicated all of Chapter 7 to it. For now, it's essential to know when a task is too big to ask Copilot to complete it. Asking Copilot to make a new video game that's a combination of Wordscapes meets Wordle isn't going to work at all. However, you can get Copilot to write a function that's important to solve a larger problem. For example, you might have a function that checks whether the word provided by the player is present in a list of valid words. Copilot can solve that problem well, and that function would help Copilot get closer to solving the larger problem. Section 3.1.1. The components of a function. The origin of the name function goes back to math, where functions define the output of something based on an input. For example, in high school math, you probably learned to recognize the common way to write a function as follows. F of x equals x squared. This is a function that is given a value for the variable x and computes the square of that value. So, we can say that when x is 6, f of x is 36. As programming functions also have expected output for a particular input, the name is apt for programming as well. As programmers, we also like to think of functions as promises or contracts. If there is a function called larger, and we're told that it takes two numbers and gives us the larger of the two, we have faith that when we give the function the numbers 2 and 5, it will return the answer of 5. We don't need to see how that function works to use it, any more than we need to know how the mechanics of a car works to use the brake pedal. Press the brake pedal and the car slows down. Give the larger function two numbers and it gives us back the larger of the two. Every function in Python has a function header, also called a function signature, which is the first line of code of the function. Given their ubiquitous nature, we'll want to read and write function headers. The function header describes the name of the function and its inputs. In some other languages, the function header sometimes includes information about what the output looks like. But in Python, you have to find that elsewhere in the code. In Chapter 2, we wrote hash comments to tell Copilot what to do. We can continue to use that approach if we want Copilot to generate a function. For example, we can use comments to ask Copilot to write a function that tells us which of two numbers is larger.
See this prompt?
As with the code in the previous chapter, we just wrote the comments to prompt Copilot to give us the code. The function header has three main components: the def keyword, which tells Python that this is a function, the name of the function, and the inputs to the function. There's also a colon at the end of the line. Be sure to include that, or the code won't be valid Python code. The word def denotes that it's creating, defining, a function. After def is the name of the function. That name should describe the behavior of the function as well as possible. The name of this function is larger. If it's hard to name a function because it does a bunch of different things, that's usually a clue that it's too big of a task for a single function. More on that later. In the parentheses of the function declaration, you'll find the parameters. Parameters are how you provide information to a function that it needs to run. A function can have any number of parameters, and some functions have no parameters. This function has two parameters named num1 and num2. There are two parameters because it needs to know the two numbers it's comparing. There can be only one output of a function. The keyword to look for when determining what the function is outputting is return. Whatever follows return is the output of the function. In this code, either num1 or num2 will be returned. Functions aren't required to return anything. For example, a function that prints a list to the screen has no reason to return anything. So if you don't see a return statement, it isn't necessarily a problem because the function may be doing something else, interacting with the user, for example, rather than returning something. Functions must also either return something or not return something. They can't return something in some cases and nothing in other cases. Although we had Copilot generate this function using hash comments, this approach is actually a lot of work for Copilot. It first must get the header right, including figuring out how many parameters you need. Then, it must get the actual code of the function right. In this example, Copilot also provided the code for the function, also known as the function's body. There's an alternate way to prompt Copilot to write the code for a function that may help it generate code more accurately, and may help us better understand exactly what we want our function to do. It involves writing a docstring, and we'll use docstrings to write functions for the majority of the book. Docstrings explain function behavior. Docstrings are how Python functions are described by programmers. They follow the function header and begin and end with 3 double quotation marks, as shown in the upcoming code function for larger. By writing the header and docstring, you'll make it easier for Copilot to generate the right code. In the header, you'll be the one deciding on the name of the function and providing the names of each parameter that you want the function to use. After the function header, you'll provide a docstring that tells Copilot what the function does. Then, just as before, Copilot will generate the code for the function. Because we gave Copilot the function header, it will be able to learn from the header and is less likely to make mistakes. Here's what the alternate approach would look like when writing that same larger function.
See this code?
Notice that we wrote the function header as well as the docstring, and Copilot supplied the body of the function. Section 3.1.2. Using a function. Once we have a function, how do we use it? Thinking back to our f of x equals x to the power of 2 analogy, how do we give the function a value of 6 for x so that it returns 36? Let's see how to do this with code by using that larger function we just wrote. The way to use a function is to call it. Calling a function means to invoke the function on specific values of parameters. These parameter values are called arguments. Each value in Python has a type, and we need to take care to give values of the proper type. For example, that larger function is expecting 2 numbers. It might not work as expected if we supply inputs that aren't numbers. When we call a function, it runs its code and returns its result. We need to capture that result so that we can use it later. Otherwise, it will be lost. To capture a result, we use a variable, which is just a name that refers to a value. Here, we ask Copilot to call the function, store the result in a variable, and then print the result.
See this prompt?
The code correctly calls larger. Notice that it puts the 2 values we want compared after the opening parenthesis. When the function finishes, it returns a value that we assign to result. Then we print the result. If you run this program, you'll see that the output 5 gets produced because 5 is the larger of the 2 values that we asked about. It's okay if you aren't comfortable with all the details here, but what we want you to recognize is when a function is being called, as in the following.
See this code?
The general format for a function call is.
See this code?
So when you see those parentheses right after a name, it means there's a function call. Calling functions as we did here will be important to our workflow with Copilot, particularly in how we test functions to see if they are working properly. We'll also need to call functions to get work done because functions don't do anything until we call them.